Hello friends, welcome to CS Tudes. Today we are going to discuss that how can we generate a transition diagram for a given transition table in case of a Mealy machine. So we have discussed the Mealy machine in our last video in which we have discussed the 6 tuples of the Mealy machine, what was the difference between the Mealy machine and the Moore machine, and how Mealy machine works and how the output is associated with each transition in case of the Mealy machine. In case you are not clear about the Mealy machine, you can go back and watch our video on introduction to Mealy machine again. Now let's continue with the generation of the transition diagram for the given table in case of a Mealy machine. Now, as we already know that in case of Mealy machine, the output is associated with each transition. And in case of the Moore machine, the output was associated with each state. Now let's draw the transition diagram for this table. Now, currently, let's say we are assuming that Q1 is our initial state. Since none of the states is mentioned to be initial, so we will consider the first state as the initial state. Now, let's start with the state Q1, taking it as an initial state. Now, currently we are on the state Q1 and we are reading the input as A equal to 0. So, we are reading a input as A equal to 0, and while reading the input as A equal to 0, we are moving to the state Q3. So, we are reading input as 0 and moving to state Q3. Now, the output associated with this transition is 0. So, we will write a 0 over here. So let's first check the meaning of this particular diagram. So it means that currently we are on the state Q1. We are reading the input symbol 0 and moving towards the state Q3, and the output generated is 0 again. So this is the representation by input oblique output. The first value is our input and the second value is our output. Now let's continue further. Now again we are on the state Q1 and we are reading the input as A equal to 1. Then we will move to state Q2. So Q2 is a different state. Let's make a new state Q2 for the transition for input A equal to 1. Now for 1 we are transiting to the state Q2 and the output associated with it is 0. So we will write 1 oblique 0. So it means that currently we are on the state Q1, we are reading the input symbol 1 and moving towards the state Q2. Now this transition will generate the output 0. So this output is associated with the transition from state Q1 to state Q2 reading a input symbol 1. Now let's talk about the second state. So in this case, our second state is Q2 and reading the first input as A equal to 0, we are moving to state Q1. So we will move to state Q1 reading the input as 0. The output generated will be 1. So we will write 0 by 1. That means 0 is our input and 1 is our output, and since the arrow is towards Q1, that means we are moving from state Q2 to state Q1 reading an input as 0 and the output produced is 1. Now, suppose we are on the state Q2 and we are reading the input as 1. Then we will move to a new state, that is the state Q4. So we will make a new state as Q4. So we are making the new state as Q4 and with the input 1, the output associated is 0. So we will write 1 by 0. That means from the state Q2 reading the input symbol 1, we are moving to state Q4 and the output generated is 0. Now the next state is our Q3. So we are on the state Q3 and we are reading the input symbol 0. So we will move to state Q2. So from state Q3 we will move to state Q2 reading a symbol 0. Now the output produced is 1. So we will write 0 oblique 1. So we are going to write over here as 1. So it means currently we are on the state Q3 and we are reading the input symbol 0. Then we will move to state Q2 and the output generated is 1. Now when we are on the state Q3 and reading the input symbol 1, then we will move to state Q1 and the output will be 1 again. So from state Q3, we are moving to state Q1, reading input 1 and the output generated is also 1. That's why we are writing 1 oblique 1. So from state Q3, we are moving to state Q1, reading input 1 and the output generated is 1. Now for the state Q4, suppose we are on the state Q4 and we are reading the input symbol A equal to 0. So we are moving to state Q4 only. That means there is a loop on the state Q4 for the input 0 and the output produced is 1. So it will be written as 0 oblique 1. So it means that we are on the state Q4 and there is a loop for the input 0 and the output produced will be 1. Now suppose we are on the state Q4 and reading the input symbol 1, then we will move to state Q3. So we are going to move from state Q4 to Q3, reading a input as 1. The output generated is 0 corresponding to this transition. So it means that currently we are on the state 4 and we are reading the input symbol 1, then we are moving to state Q3 and the output associated with this transition is 0. So this is the complete transition diagram for the table given to us. So in this way, a small delta, that is our transition function, can be represented in the form of a table, in the form of a graph and also in form of a function. So now let's see that how it can be represented in form of a function. So let's first delete the graph which we have drawn over here and then we are going to discuss about the transition function. Now let's talk about the transition function. So transition function is represented using delta. So it's a small delta and we are currently on the state Q1 and reading the input symbol as 0. So the output, so the state to which we are going to move will be our state Q3. So this is the transition that we are currently on the state Q1 and reading our input as 0, then we are transiting to a new state Q3. Now if we want to check what is the output associated with this particular transition, then we are going to use lambda dash. So in case of lambda dash, we will write Q1 and the input associated with this is 0. So the output generated will be 0. So using delta and lambda dash, we can find the next state and the output associated with this transition. Now let's take one more example. Suppose we are on the state Q1 and we are reading the input symbol as 1. Then we are on the state Q1 reading input 1. We will move to state Q2. So we are moving to state Q2. Now let's check that what is the output associated with this transition. So state is Q1, input is 1 and the output associated with this transition is 0. So we will write over here as 0. Now let's take another example. Suppose we are on the state Q2. So we will write over here as Q2, comma, then the input is 0. So we will write 0 over here. The state to which we are moving from Q2 on reading 0 is Q1. So we will write over here as Q1. Now let's find the output associated with this transition. So lambda dash Q2 comma 0, then the output associated with this transition is 1. So we are going to write over here as 1. Now for Q2 comma 1, so we will write Q2 comma 1. That means we are currently on the state Q2 and we are reading the input as 1. Then we will move to state Q4. So the next state is our Q4 and the output associated with this transition Q2 comma Q1 is equal to, let's check over here, it's 0. So we are writing over here as 0. So in this way, we can write all the transition in the form of a transition function and all the outputs in the form of a lambda dash. So as I have already told you many a times that we can represent delta, that is a small delta, means transitions using three of the ways, that is in the graphical representation using transition graph or transition diagram. We also call it as a state diagram. or in the form of a function that is known as transition function, or in form of a table that is known as a transition table. So that's all about the representation of the Mealy machine in form of a table, in form of a graph, or in form of a function. So stay tuned with our channel CS Tute. Please like and subscribe our channel CS Tutes. In case of any queries, you can leave the comment in the comment section below. Thank you.